Hi everyone, this is going to be our note for 5.4, the cosine law in acute triangles. So last lesson in 5.3 we learned about sine law, and that was a method in which we would find the unknown sides or angles if we didn't have a right triangle. We learned about right triangles and we can use primary trig ratios, the SOHCAHTOA stuff, but if we had like an acute triangle like this where there's no 90-degree angles, we needed other methods. So sine law was one of them. And the other method we're going to use is cosine law. So first, let's go over the equation for cosine law. So just looking at this triangle again, remember capital letters represent the angles. Notice how these capital letters are by the vertices of the triangle. And the lowercase letters are always opposite that angle, and these are the sides. So if I want to find side A of this triangle, the equation is a squared equals b squared plus c squared minus 2bc cos a. So normally you would have to know what this is, memorize it, but because again, our circumstances, when you do the homework or do your assignment, you will have access to look at these. So you don't have to memorize them, but if you need to memorize them or you want to memorize them, I don't think it's, the most difficult thing. It kind of looks like Pythagorean theorem. That's because it was actually derived from Pythagorean theorem. So if I want to find for side B, so if I want to solve for side B, well, I'm going to put it as b squared. And the way I remember it is, if I'm having b squared side B here, at the other end is going to be angle B. And then we're doing cosine law, so for the angle, we're going to have cos beside it. And then the rest is just going to be the other letters that I haven't used yet. So we have a squared and c squared minus 2ac cos b. Sorry, just a quick edit to make that look a bit nicer. And if I want to find side C, well, I'm going to write that as c squared. And then if it's c squared here, we need the angle of c, so cos c. And then just the other two letters we used are a squared and b squared minus 2ab cos c. So just a reminder, when we're isolating for either of these sides or either of these letters, we have a squared, so the opposite of that is square root. So if I want to find our answer, we're going to have to eventually take the square root of both sides near the end of our calculation. That's if we're solving for an unknown side. So again, don't worry about having to memorize these. You'll have access to this either from this video. They're also in your textbook, so when you do your homework and assignment, please don't be afraid to look at the equation to help you do the homework and stuff, answer questions about it. So we can also use cosine law to solve for angles. So if I wanted to solve for one of these angles here, I could do a bunch of reorganizing to isolate for this angle, but I will just give you the equations for these as well. So if I want to solve for angle A, and I rearrange this, I'm going to get cos A is equal to b squared plus c squared minus a squared over 2 times b times c. And these are all the side lengths. So if I wanted it for angle B, well, cos B, the angle, and then it's always the minus, whatever the angle is, it's going to be minus that side. And the rest is just the other letters. So we had a squared plus c squared over 2ac. And then if I wanted angle C, cos C, and then side C is at the end, minus c squared, and then a squared plus b squared 2ab at the bottom. So these are equations. I'm going to be referring back to them when we get to our examples. And again, you will have to refer to them when we do the homework. Remember also, when I'm solving for angles, at the very end, I want the angle here. So I'm going to have to do a inverse, which is the cos -1, and that kind of decimal over here. That's what this bubble reminds you of. So if I'm solving for a side, remember to square root both sides at the end. And if I'm solving for an angle, remember to do the inverse, which is like second function, like the cos -1 for this equation. So the last thing we need to know is when do we use cosine law? Because sometimes we can't use it, and sometimes we'll have to use sine law instead. But so there are times where we can't use sine law, so we have to use cosine law. So when does that happen? Well, if I know 3 side lengths and no angles, or if I know 2 sides and the contained angle. And what I mean is if I had a triangle like this, and I know these 2 sides were like 5 and 6, I can use cosine law if I know the angle in between. That's the contained angle. So the contained angle is just the angle in between the 2 sides that I know. So let's get to an example. So example 1 says, in triangle ABC, side A is 10 centimeters long, side B is 12 centimeters long, and angle C measures 40 degrees. Determine the length of side C. So, like always, we make a diagram. So just draw a triangle, just like I did in the last lesson. Doesn't matter what it looks like. A, B, C. Capital letters for the angles. Side A, well, side A has to be opposite angle A, is 10 centimeters. And side B, which is opposite angle B, is 12 centimeters. And angle C measures 40 degrees. Well, here's angle C. This is 40 degrees. So I have 2 sides and the contained angle, the angle in between these 2 sides. So I can use cosine law. So they want us to determine the length of side C. Side C is here, and that's what we're trying to solve for. So what is C in this case? Well, I'm solving for a side, so I can look at my side equations for cosine law. I'm going to use, well, C is convenient here, so I'm going to use that one. I have C squared is equal to A squared plus B squared minus 2AB times cos C. So I just always kind of do this, not really a trick, but I always just put brackets here, because what I'll find is students will subtract 2 or something and not follow the bedmass, because this is all multiplication, so I would treat all of this as one thing that we have to do, and then we're going to subtract that from whatever these are. So let's fill in what we know. Well, we know A squared, well, we said A is equal to 10, so this is 10 squared. Sorry, C squared is equal to 10 squared. We said B is 12, because it's side B, so it's going to be 12 squared. 12 squared minus 2 times A we said is 10, B we said is 12, times cos, and then we said angle C is 40 degrees. Sorry, I just put some brackets around these just to remind us we're going to do all this multiplication together. So let's follow our bedmass. I see exponents, but there is brackets first, so I should do everything in the brackets. Even if I didn't do, because I know I put these brackets in here, I would do the exponents first, and then I would multiply all these, and then I would do the addition and subtraction. So either way, I'm going to be doing this all together anyway. So I just do it all together just to make sure I don't forget, because I do find students forget to do that. So what I'll do is, again, a common mistake for students to make. Not everyone will, but I just find students make a mistake at this point. So remember, multiply all of these together. What I do first is the cos 40, and I get this decimal, and then I just times it by the other numbers, and I keep this number in here, so I get all the decimals, times by 12, times by 10, times by 2, and I get 183.85. So then I can do the exponents now. If you wanted to do this all in one step, you could just do it all in one step. Okay, so now I can just add and subtract these. If I do that, I just go straight to 60.15, and that is equal to c squared. So remember now, this is c squared is equal to this. And also, if you think this is the answer, and this is c is 60, well remember this is 10 and 12. That's a big jump from, 10 to 12 to 60 for length. So remember, I have to square root both sides. And if I take the square root of 60.15, I get 7.76. So, therefore, side C is 7.76 centimeters, which makes a bit more sense than the 60. So remember, at the very end, when we're solving for sides, you have to square root both sides. Sorry, just noticed an error, but it actually doesn't affect our answer because the answer that we had is actually correct. This 7.76. So I did this 12 squared. This shouldn't be 121. That's 11 squared. This should be 144. But if I add these together and subtract it, I still get the 60.15. So I apologize for that. If people were yelling at the computer, how did you get 121? I just kind of did it quick when I didn't look at my sheet. But this should be 144. But again, it doesn't matter because these are all the right answers. I just made a small error there. So sorry to confuse you there. All right, example 2 says solve triangle x, y, and z if side x is 10 centimeters long, side y is 11 centimeters long, and side z is 12 centimeters long. So if the question says to solve the triangle, solve means find all the sides and all the angles. And if you're like, that's a lot of work, it's not a small amount of work, so you're right. But you'll have to do it anyway. So let's just draw a triangle for x, y, and z. That looks like a triangle. I'm going to put x, y, and z for our angles. And then it said side x is 10. Side y is going to be 11. And side z is going to be 12 centimeters. So what do we know? Well, let's just write down all our stuff again. Y is equal to this. Z is equal to, oops, sorry, I didn't do x. X is equal to 10 centimeters. So we can also use cosine law, we said, if we know 3 sides. And if I know 3 sides, I can solve for actually any angle that we want. So let's just choose an angle randomly that we're going to solve for. So I hear all your guesses. I think most of you, yeah, okay, we'll do angle Z. So I'm going to solve for angle Z. So here's a bit of a problem with our equations. We learned everything with A, B, and C. So now what do we do if we have X, Y, and Z instead of A, B, and C? Well, you have a couple options. You can just, if you want, relabel this so you remember. You can say like, well, A is equal to X, B is Y, and C is Z, and then just kind of replace them afterwards. But if you understand the equation, you can just substitute the letters in yourself. So that's what I'm going to do. But again, if you just want to make, A is equal to this, B is equal to this, C is equal to this, and change these ones too, you can do that as well. Just, you'll have to change them back and try not to make a mistake. So I'm going to start with angle Z, we said. Well, sorry, this is side Z, but I want to find angle Z. So I want to write my cosine law equation where I'm solving for an angle. So I'm going to have cos for angle Z. And I know in my cosine law, if it's angle Z, it's always going to be the minus Z squared at the back. And then the first two are just the other letters that we have. So y squared plus Z, oops. Again, these orders don't matter, but I'll do an alphabetical order. X squared plus y squared over 2xy. So I'm using all three of the sides here, and the minus part is always for the side opposite the angle that we want. So we have cos z, because I'm solving for this, and we're just going to fill these in now. So we said x is 10 squared, y is 11 squared, and z is 12 squared over 2 times 10 and 11. And I just fill these in based on our sides that we had here. So following BEDMAS, we get 100 plus 121. That's why I got the 121 before it by accident. I went a bit too fast. And this is minus 144. And then I'm going to divide after I add and subtract these. I'm going to get over 220. So I'm just going to do that to the top now. So we have 100 plus 121 minus 144, and we get 77 over 220. And remember, all of this is equal to cos z. So remember, when I'm solving for the angle now, I have to do the inverse of that. So I'm going to get the cos -1 times, well, inverse of cos for 77 over 220. And you could turn this to a decimal, remember, to 4 decimal places. But if you want to just put it as a fraction and do that all in your calculator, like put it as a fraction, your calculator can just do that all for you as well, if you don't want to worry about rounding decimals. Also remember that your calculator has to be in degrees, should say, can't really hard to say here, but DEG, or the letter D at the top. If it's in something else, you're going to get different answers. So I'm going to do my inverse of cos, and I'm just going to write it as a fraction in brackets, 77 over 220. And I'm going to get, angle is 69.51 with rounding. So angle Z is 69.51. So we can change this now. Okay, we got one angle. So now we got to solve for one of the other angles. So let's solve for, okay, angle Y. So I'm just going to do that over here. We're going to have to use cosine law again. I guess, you know, I do have Z being 69.51 here. I have an opposite angle inside. I could use sine law here, technically, now that I know this. But just to be safe, in case I made an error here, maybe there's a mistake here, I'm just going to use the numbers that the question gives us. So I'm just going to use cosine law again. So I'm going to use cosine law again, except for, we're going to do for angle Y. So cos Y is equal to, well, I already know it's angle, so the opposite is going to be that minus y squared, meaning the minus will always be opposite to what the angle is, so y and y. And then x squared plus z squared over 2xz. Because again, these are just the other two letters. So then I fill in what I know. We said x squared is 10 squared plus 12 squared minus 11 squared over 2 times 10 times 2 times 10 times 12 on the bottom. So I'm just going to zoom in a bit here in case people are having trouble seeing that. So all I did was I substituted our letters in, and I'm solving for angle Y now. So I'm going to do my exponents. 100 plus 144 minus 121 all over 240 if I multiply these together. And then I can subtract the top. I'm going to get, sorry, add and subtract, just simplifying the top. I get 123 over 240 is equal to cos y. Remember, I'm solving for an angle, so I got to do the inverse of that. So cos -1, 123 over 240. So I'll show you again on the calculator. I just do second function, cos button. Should probably show the buttons. Second function, cos button to get the cos -1. Then I'm just going to put in brackets. I'm going to put the fraction in, 123 fraction button, that's my ABC button, that one, over 240, and I get 59.17, let's say, if I run into two decimal places. 59.17 is going to be our angle Y. So now for the last angle, what I would normally do is, to be safe, I should do the whole cosine law again for angles x. But I know you're thinking, well, if I know two of the angles, I can figure out the third angle. So for argument's sake, yes, if we did everything correctly, we made no mistakes, I could just do 180 subtract 69.51 subtract 59.17, and I would get 51.32 degrees. So I know all three angles have to add up to 180, so I just 180 subtract angle Z and then subtract angle Y, and the leftover has to be angle X. So if I used cosine law here, and I did it on the side already, I'm telling you we're going to get the same thing. So I should be able to add all these up. They should equal 180, and they do. So that's it. We found the angle. Well, we solved the triangle. We found all the angles, and we know all the sides. All right, our last example, example 3 says, two cyclists leave from the same location at an angle of 63 degrees between their paths. John cycles at an average speed of 15 kilometers per hour, and Marcos an average speed of 20 kilometers per hour. How far apart are they after 3 hours? So we need to usually get some distances here, but we know how fast they're traveling, and we know how long they've been traveling for. So if we have like John, and he's traveling at 15 kilometers per hour per 1 hour, well, how long would he be at 3 hours? How far, sorry? Well, 1 hour times up by 3. I would do the same to the top. I would get 45 kilometers after 3 hours. And then I could do the same thing for Marcos. And do, well, he is traveling 20 kilometers per 1 hour. And after 3 hours then, well, we times the bottom by 3 times the top by 3, we get 60 kilometers. Some of you might have figured out without showing this work. That's fine too. But I just wanted to get the distance after 3 hours. So we know that John and Marcos start at the same spot. So let's just draw that. They start at the same spot. But then they go in different directions. Let's say John goes this way, and Marcos goes this way. The reason why I drew Marcos a little bit longer, because he traveled 60 kilometers here, while John only traveled 45 kilometers. So I just drew that one line longer. And then it said the angle between them is 63 degrees. So this is 60, this is 45. They want to know how far apart are they after these 3 hours. Well, if John landed here and Marcos landed here, what is the distance between them? Well, by me drawing this dotted line here, hopefully we can see that we have a triangle. So I can figure out the distance between them by using cosine law, because I have two sides and the contained angle, that's the angle in between these two sides. So we're just going to use cosine law here. Let's actually just make up some letters. Let's just call this A, B, C again. And I'm trying to find what letter. Well, I know angle A is here. I want to find this distance. This is opposite angle A. So I'm trying to solve for side A. So I don't actually have to solve for everything here. I just want to solve for this one part for this particular question. So our side length equation we said is A squared is equal to B squared plus C squared minus 2BC times the cos of A. Again, A on both sides. Side here, angle here. And then we know our different values. We said that C is equal to 45, B is equal to 60 based on our triangle diagram. Angle B is here, B is 60, and C is 45. And what we're going to see too is that it doesn't matter which one is which. We should get the same answer either way. So I'm going to get B is equal to 60 squared, C is equal to 45 squared, minus 2 times 60 times 45 times the cos of angle A, which is 63. So I'm going to just put brackets around here just to remind myself I have to multiply all of this together. But I'm going to do the exponents here and then multiply this all in one step because I can do that. So that squared is that. 45 squared is 2025. And if I multiply all of this, I get 2,451.55. And then if I add and subtract these to simplify, I get A squared is equal to 3,173.45. And remember, I'm solving for a side. I want just for A, not for A squared, so we're going to square root the other side. And I'm left with 56.33, which kind of falls on the realm of these numbers as well. So this makes sense. So how far apart are they? Therefore, they are 56.33 kilometers apart. So your homework's at the bottom. If you need help, we can work out some office hours, and thanks so much for your time.